Okay, here's question 21. Question 21. This is quite a unique question. The first thing I recognize is that there's a star next to the question. And the question says, prove algebraically that the difference between the between the squares of any two consecutive integers is equal to the sum of the two integers. So, although quite short, there's quite a lot here, and this question is worth 4 marks. So this comes under the heading proof, right? So proof has become quite popular in the exam, especially at the upper end of the higher paper. Let's read through it again. Prove algebraically that the difference between the squares of any two consecutive integers is equal to the sum of these two integers. So I'm going to start off by saying let n be the integer. Now, an integer is a type of whole number, so we're going to say let n be that. So n and n plus 1 are consecutive integers. Consecutive means one after the other. So the numbers 2 and 3 are consecutive because 3 comes after 2. So consecutive numbers are numbers that are coming right after each other. So if a particular number is n, the number directly after it is n plus 1. So those two are two consecutive integers. And this question says the difference between the squares of any two consecutive integers. Well, the difference, that means I'm taking away. And so if I square n plus 1, that's going to be the bigger of the two. If I square it and I square n, right, the difference between them, I need to work that out. I need to show that the difference between them is equal to the sum of the two integers. So it's equal to what you get when you add the two numbers. So this is the difference of the two consecutive integers. Now n plus 1 all squared. N plus 1 all squared is n plus 1 times n plus 1. I still have that minus n squared there. N plus 1 times n plus 1, n times n is n squared, n times 1, and then 1 times n. Altogether that's going to give me 2n, and 1 times 1 is 1. So you should be familiar with working that out. Minus n squared. Now, that n squared there is going to cancel out with a minus n squared, and all of that just leaves me 2n minus 1. Okay, so what we've just worked out is the difference between the squares of two consecutive integers. Okay, now they said prove algebraically that the difference between the squares of any two consecutive integers is equal to the sum of these two integers. So I'm going to work out now the sum of the integers. Well, we said one of them is going to be n. The other one is n plus 1. And the word sum means to add. If I add these, that's going to give me n plus n, which is 2n, and plus 1. These two are the same, right? So I'm going to put a line because both the sum of the integers and the difference of the squares of the integers is 2n plus 1. I made a mistake here. That's a plus 1. The proof is shown. Okay, so that's enough there to actually prove this enough. If I sort of zoom back out a bit. Okay, so that there is the complete solution. Okay, follow that through, think about it, especially for those of you aiming for A's and A stars. You should be able to follow that, do that, and do something similar to that. And especially because there's a star next to this question, there's marks for the quality of your written communication, so make sure you state it all clearly and you can give and show all your workings and your proofs.